what we're trying to do here is we're trying to take sort of the best of these systems, okay? The actual relevant data according to the science that we find to create a system that takes all the necessary information to get this eye, whether it's for a new laser, whether it's for repair of a cornea, to get as smooth a optical system so it scatters light as little as possible, a very uniform anterior cornea that we based on, that we can create a system that gives us the best possible vision this eye can do. That the only way to get more vision out of an eye would be to increase the photoreceptors, the megapixel of the eye, which we'd have to figure out how to change the nerves, the nerve layer, which is part of the brain, maybe in the future. But right now, this is about as good as we can do. And so what we want to do is we want to base it around the highest level of resolution, which is the corneal system. The corneal system, by making a very uniform cornea, you can actually get incredibly good vision. The problem is that when you make that very uniform cornea, there are sources of error otherwise, and that's where the other parts of the system come in, okay? So what we want to do then, we make a uniform cornea with this and with the 032 patent, but we have the problem where the epithelium can hide some of this. Now what happens is the epithelium tries to blunt the ripples in the cornea, and it actually can thin and thicken depending on high and low spots. The problem is none of these other systems can see this. The only thing that can see this is an epithelial mapping system. So to avoid error and miscorrection or undercorrection of the flaws in the corneal higher order aberrations, we actually have to also use the epithelial map, okay? And that epithelial map has to be combined with the map of aberrations to show how much of those flaws, those aberrations, higher order aberrations, that the epithelium is actually hiding, okay? So that's critical, because once you have this, and let's say you probably have a pretty normal epithelium blanket, where it doesn't really thicken and thin. Well, that happens in a lot of primary corrections. Then this is good. Then we have this. We don't even need to add this because it essentially becomes a zero addition, okay? But in a lot of other cases, it's actually very pertinent and becomes a significant source of error in a certain percentage of cases, especially when you get into repairing corneas. Because the key here is we want to be able to not only fix primary corneas, but the very, very lucrative market that really has very few people serving it of damaged corneas from disease, from trauma, from infection, from past surgery. These are really, really important, and we think just the United States, there's at least 1 to 2 million people, if not more, worldwide, even more. Okay, so for those patients, the epithelium compensates quite a bit more.